Now we're recording. So let's go from current. I don't know if you've noticed. It was stuck on 2 seconds for a long time. So now it's recording more normal. Okay. Let's get to where we left off. And tell me what's the last thing we were doing. Yeah, I've got to get my pen back. It's slow. There, we got it. It was 2 times 2 2/3. Okay. And I thought probably the best way to go here would be 2 times, and that would be 8/3. And we did that, didn't we? And that would be 16/3. And that should be the answer they got here. All that was our last step. Okay. Now, any questions on example 1? That took forever because of the stupid computer. Okay. Now, I want to show this figure before I do that. It's not going to show it. Okay. But it's equivalent. Okay. Your figure 5 in the text is not the same as this one, but somewhat similar. Now, remember before when we were doing integrating under a curve, we usually have to let the curve stay positive. If you're integrating differences between 2 curves, all that's required is the top curve be greater than or equal to every point at the bottom. So here the bottom curve is negative. Doesn't matter if integrating the difference between them. The difference between this would be this minus this. So this is a negative number. This is this minus would be plus. That will work fine. Okay? It would even work fine if you lowered this so this function has some parts of it less than 0. Notice what? Because as long as this one stays less than or equal to it. So this can come down here, and as long as it's tight and just cross it, you can still do that. So now we're not restricted to either or both functions being positive. The only requirement is that the top function be always better than the bottom function, even if one part of them is negative. Okay? I guess I should have formed that up. Got to. Okay. All that it matters is that the top function is greater than the bottom. Or equal to that would be fine too. Because the subtraction takes care. It doesn't matter if this is negative, you subtract the negative number you add it. So basically this function minus this function, if this is negative, then you add it. So it works out perfectly fine. And these are your Riemann sums that you put that in you didn't worry about Riemann sums before. Why are we reintroducing them? Well, they're still there. They still do the same thing as before. It's the difference between these two. The height of the rectangle is the delta. But the delta is 0. Okay, does that make sense? All right, so let's back up and show this, which is basically the same thing we did before. Area between the 2 graphs, identical A to B, the y on top minus the y on bottom is the all that's required here, you don't have to require the F or G always be positive. That's no longer required. It's just always required to be positive. Either one of them could be positive, negative, partially positive, partially negative, as long as it's not everywhere between A and B. Outside A or beyond B, yeah, the Paul says doesn't matter. That's the part you're integrating. Needs to always be. In other words, what's inside the parentheses has to be not negative. Okay? So let's do example 2. which is this one. Find the area between the graphs of f of x, which is, I'll blow it up for you just to see it, but as soon as I start writing, I'm going to have to reduce it again. Here's your f of x, which is x squared minus 5x minus 7. And here's your g of x, x minus 12. A linear function, a quadratic function minus a linear function. Find the area between those graphs. Now this one, if they hadn't graphed it for you, if this was on a test, you better graph these two. You got to, because if you just try to integrate from minus 2 to 5, is that what it says? Yeah, minus 2 to 5, without regard to where the graphs are, you're going to get it wrong. Okay? In this case, if you did f minus g, you would look out into getting, you would get a positive answer, and you might get this right. Okay? So you have to graph these, and they have already done the work for you here. You see, this is even a factorable function. It's not that you have to get zeros to quadratic formula. It's a messy quadratic. But who cares if it's a messy quadratic? What it is you need to know who's on top. Okay? Which one is the upper one? Now, easy places to keep graphs is even x equals 0, the y is equal to -7. And there's that one there. X equals 0 here, this is minus 12. So guess what? You know right now that the first portion, F is there. Okay? But the things to check next, especially if you just do a sketch of it, so you know I fix this calculation. What you need to find out what to do about it. Now, say that. The first thing you do then, I have to shrink back, is say, find the places where f of x equals g of x. Okay? So let's do that. That would be x squared minus 5x minus 7 is equal to x minus 12. How do you solve that? Say that again. Okay, subtract the x on both sides, is that what you say? Is that, huh? I thought that was, okay, subtract the x on both sides and add 12 to both sides. What does that give you? X squared minus what? 6x plus 5 is equal to 0. Why do we want to do that? Crazy idea. Huh? Yeah, this is, my pen went really wacko here. Okay, equal to 0. Okay, well, we hope maybe we can, yes, there it is. Okay, how do you do that? Let's see if we can factor it. Couldn't factor that first one, but that doesn't mean you can't factor this one. What might be your factorization method? X times x, I buy that. Minus and minus, I'll buy that. 5 and 1, okay? So where are your 2 points of intersection? And positive 1. Okay, sure enough, there they are. Okay, now, we've already done something here. Remember when we plugged in x equals 0, we knew that alpha is greater than g below 1. Let's put something to the right of 1. like maybe 2. Well, let's plug that in. 2 squared is 10. That's negative 50. Negative 10. So sure enough, G is greater than alpha Q. So that means, okay, let's check out, oh, we're only going to 5. Fantastic, because we don't have to check any further. So that means that from negative 2 to 1, we have this interval. And from 1 to 5, we have the other. Okay? So that's how we find the area between the two functions. Okay? First thing you got to do is sketch. They sketched it for you, but you can investigate it really without sketching, but sketching usually is helpful, especially if you have a scientific calculator. I mean, not a scientific, graphing calculator. It's fairly easy to get that done. So our integral would then be the integral from minus 2 to 1 of f minus g, and that would be x squared minus 5x minus 7. Now, after a while, I think you can do this, minus x plus 12, right? dx. Which basically gives you exactly what we got before, integral from minus 2 to 1 of x squared minus 6x plus 5 dx. Plus, I didn't leave room to write it there. Now the second part of the integral would be from 1 to 5, and that would be what? X minus 12 minus x squared plus 5x plus 7 dx. Okay, I'll put it in parentheses, okay? And let's simplify that one a little bit. That's 1 to 5 of minus x squared plus 6x plus 7. No, plus 5, sorry. No, I think it's minus 5. See, again, skipping too many steps can get you in a yeah, that's minus 5 dx. Well, all we have to do is pull out the minus sign and you got the same integral. So what we have is the integral of, from minus 2 to 1, of x squared minus 6x plus 5 dx. And let's just pull out the minus sign and have the integral from 1 to 5 of x squared minus 6x plus 5 dx. Right? Well, those are the same things. So now we can, well, yeah, but okay. Can we combine these? Why not? Limits, yeah, this is going here, this is there. So you can't do it. You can if they're the same limits, you could combine those. It's not if they're different. So you just have to do these. But it's going to be the same integration. So you only have to integrate once then. So what does this give you? Let's do the antiderivative. What do you get? X cubed over 3, is that what you said? Okay. Minus what? 3x squared. Good, I can't hear well, sorry. And
plus 5x. Okay? And we'll evaluate that from negative 2 to 1. And then we'll have the same thing, x cubed over 3 minus 3x squared plus 5x, evaluated from 1 to 5. Right? So let's do it. Okay. Come out again here. Plug in the 1 here. You go there. Then you go plug in the 1 here. You go get that same number. You go get the 2. Remember that. That's where it might get you into trouble. So let's do this. So let's plug in a negative 2. So that's going to be a minus. And when you put a negative 2 in for x, what does that give you? Okay, it's going to be a negative 8/3, right? So minus a negative 8/3, okay? And then it's going to be a plus you're doing the minus 2. I'm changing the signs because it's negating, right? All right, that 12 came in handy there, didn't it? Okay. And minus 10. Okay. Okay, it's not a negative up front. That was the minus for the negative 8/3. You see, this minus is from fact. See, I changed the sign to minus, plus, minus. So what minus is, so this is the front. So that is out front only at this, not and then this turned out being minus and put in a minus 2 here. So that became a positive. And a positive and a minus. So this came out, what's that? 2 2/3. 14 2/3 minus 4 2/3. If you want to do it. Yeah. You see that? Okay. 4 2/3. Okay, that's that part. Now let's do a minus in front of all that. So I'm going to go on and negate each of these again. So that's going to be a minus 1/25, right? Then a plus, because I'm negating it. What would that be? Say again? 75. Okay. Minus 25, right? By that? Okay. All right. I got it. Keep swampland out of Florida, so not that much. Okay. So that's going to be a 50 here, right? And this is going to be a negative 41 2/3, isn't it? So this will be a 49, it's a negative 41 2/3, so positive 49 3/3. So that would be added it together. What did that give you? Cases. Let me draw that line a little bit better. Here we're adding these two numbers right here. That's a 49. And a third. Positive, right? Got it? So plus 8 1/3. What's that going to be? I get 13. Can it be that easy? No. No, wait. Yuck. I must have made a dumb mistake somewhere. Let's see what they get. I know, and that's nowhere close. What's what? Right. Right. Yeah, so that's what I did. I already did it. I made that minus and plus that minus. Oh, well, I may not have done it. Okay, yeah. That's what I intended to do, but I think I messed it right here because it should be a minus thing. So that should be a plus thing. That's where the error is. That's a plus. Yeah. I was doing it too fast. Always a problem there. Okay. So this made it, everything's plus up here. So that's, what's that? No, the 12, okay. Like you were saying, it's a minus. I take that to a plus, but when you plug in a minus 2 here, that becomes a plus 4. Plus 3, that is a plus. But here's where I messed it up, because I made that a minus 5 times a minus 2 to a plus 4. I only put one of them minus 2 in my plus. That's where the error is, right there. So this would be 22, and this would be plus 2 2/3. So that would be 24 2/3, and then add to that 8 1/3. It still doesn't give us the right answer. That's the 33. And they got 37 2/3. So did I do the same dumb mistake there too? No, I don't think so. I made that a minus plus minus 1/25. I hate it takes this much time to do something that's just a really dumb problem. That was a minus. That was a plus 75. And that was a minus 25. So it's a plus 50 and a minus 41 2/3. It's 8 1/3. I can't see that error now. I sure hope they haven't made a dumb mistake and I'm doing all this for nothing. But we're awfully close. I've just made a dumb mistake somewhere and I don't know where it is. And maybe I can't do what I was saying before, but I'm pretty sure I can. It wouldn't be this close if I could. Their answer is 3:37 2/3, and I got it 33. So there's some little error somewhere here, and I just don't see it. But I think what we did was right. You can go back and do it the way they did, brute force, carry it all the way through. I don't even see how they got their numbers. They did them so weirdly. They skipped more steps than I did, so I can't follow it. But I don't want to waste any more time doing it. But you see, we came out in the right ballpark. The principle is there. Top of minus bottom sphere minus, top minus bottom sphere. So, I may have just done something really dumb there. I don't know. Let's move on to example 3. Sorry about that. Oh, wrong thing. There we go. All right. Now, example 3 is calculating area by dividing the region, which we just did, but this is dividing the region for a different reason. Okay? Find the area of the region bounded by the graphs of y is equal to 8 over x squared. I'm going to go on and blow this up so you can see it a little bit better. Hopefully. And that's this curve right here. 8 minus x squared, or at least the first quadrant portion of that. Okay? Y is equal to 8x, that's this one here. Now, of course, if you look at the graph here, they've expanded the x scale and compressed the y scale. That doesn't look like it's supposed to be what it is. So this y is equal to x. You would think that would be here, because this scale is here. But it looks like they've got it right. Okay? Those are the three. Y is equal to 8x is there, and y is equal to x is there on their scale. Now, what we have to figure, though, is where the points of intersection are. Now, they've shown you here, but I don't think it's fair to do. What we have to do is say, well, this is equal to that. So let's do that one first. I'll have to shrink it to do that, where 8x is equal to 8 over x squared. Where is that? How would you solve that equation? Multiply x squared by both sides. That sounds like a good thing to do. And that would give you 8x cubed is equal to these go away. 8. Now what? Divide by 8. And that gives you x cubed is equal to 1. And where's that to? At x equal 1. Now it's true at two imaginary places too, but we're in the real system, so that's the only one we're going to worry about. Okay? You have to also do it down here. 8 over x squared equal x, where these two come into play. And what would you get there? So again, multiply x squared by both sides. That sounds like another winner, if I could write. Okay, and what does that give us? Okay, just a second. You get 8 equal x cubed, And what's your answer there? X equal 2. So sure enough, they did choose the right things.
Okay? Now, if you're doing the area enclosed by those three curves, you do the first part from 0 to 1. Oh, and the other one is the opposite of X. So those are okay, so the 0 to 1 of this minus that. 1, 2 of this minus that. All the upper ones go. So here's the first one.
So let's do that. What's that first integral? It's what? Positive eta, is that what you said? I couldn't hear. Okay. You're going from 0 to 1, right? Of 8x minus x. No, okay, wait.
This first one right here, you're going from this line to this line. Stay there. Yeah, we get it back. All right. Here, we do this.
8x minus x dx plus, and what's the second part? The integral from 1 to 2 of what? 8 over x squared minus x dx. Okay. I'll do the first one for you. 0 to 1 of 7x dx. Okay, I'll do that subtraction. Okay. You do this one for me. What do we do with that? I was thinking of a real complicated way to do it, but let's keep it simple. We won't have the other way. Okay. That would be, I don't like to write x's in denominators. How do I write that? 8. Is that what you were saying? I couldn't hear it. Oh, okay. Okay. Minus x, right? dx. Okay. Now, I want you to do both integrations because this is what the class is about. Integrate that first one. Say again? Over what? 2. Got it. That's evaluated from 0 to 1. Plus say again? I don't think so. The 8 is right. Oh, 8x what? Oh, 8x to the minus 1. I'll buy that one. Over minus 1. So I'll just put the minus in front, right? Okay with that? Okay. Next part. Got it. That will be from 1 to 2. So plugging in that, what would you get? 7 over 2. Done. I did the bottom part with the 0. Okay, plus. Now, what would that be? That would be a minus, plugging in a 2. It would be 8 over x, right? Is that x, 8x to the minus 1? Okay. So that would be 8 over x. Plugging in a 2, that would be a minus 4, right? You buy that? Okay. Minus, and then plugging in a 2 there would be 2 squared, which is 4, over 2 would be 2. Got that? Then we subtract the minus, okay, which means those both become pluses, right? When you're subtracting the part of the plug of the 1 in. This part with the 2 negatives here, and then subtract the 1 with 1 right? The subtraction is going to make those 2 pluses, right? So that would be plus what? Plus 8 over 1, which is 8, and this would be plus 1/2. We wanted our fraction. We didn't want to get away without a fraction there, did we? Okay? Now, this will be a minus 6, plus 8 would be a 2.5. So this would be a 3.5 plus 2.5 is going to be 7/2 is 3.5. This gave us plus 2.5, right? I'm sorry. Okay? What would that give us? What would that give us? 6. All right, that seems way too easy. What did they get? Oh, look at that. They got 6. Good for them. All right. They may have messed up the previous one, but they got that one. Good for them. All right. Any questions on that? Okay. What if we had a mess like that? You reckon we're going to do that? Blow it up. We don't want to look at it. No, okay. Bigger so we can. All right. What if you're trying to find the relation between y is equal to y, x is equal to y squared minus 9 as the y-axis? You want to try to do it? Yes. Alright, so it's got this in terms of y, and the y-axis is for x equals 0. And if you did dy here, then the difference here would be that's 0, right? And when you watch this here, you look like this is 6. This, right? This is 0. Now, here
would be 0 minus this. So you'd be minus this one. Flip it around. So that's the minus 3 to 3. And then you get that. Unless you get real lazy on this and you say, but wait a minute, these are exactly the same, these are exactly the same. So whatever happens to this thing, I'll do this. I don't know if they actually do it or they just talk about it. Okay.
Yeah, they sort of do it. Okay. I think. All right. Now. I can't believe they're doing this though. They're not doing what I just said. They're saying the signed area, not the total area. So they're letting this minuses subtract off from the pluses. They're not doing the area between those. They're doing the signed area between that. They're letting those subtract off from those. So that isn't what we've been doing, but they are allowing that. So I guess we have to do that too. So this is just simply then the integral from minus 6 to 6 of y squared minus 9 dy. That's all they're doing. Sorry, I thought they were actually doing like we did before. Taking this total area. They're not. They're saying what is the signed area. When they say signed area, that lets you subtract negative areas from positive areas. So let's do this. This is pretty simple then. What is that? Antiderivative. Y cubed over 3. Is that all? Minus 9y evaluated from minus 6 to 6. Okay, now, again, I don't want to do that. I want to do twice this from 0 to 6, because those are exactly symmetrical. So I'm just going to double it and go 0 to 6. And that makes life somewhat easier. Okay. All right, so this will be 2 times, now you plug in 6 cubed. 36 times 6, 216, okay, over 3, 72, so it'd be 2 times 72 minus 54, that'd be 2 times 18, and that's sure enough what we got, 36. Okay. That's the signed area. In other words, you're letting the minus subtract from the plus. You're not reversing the order of integration, adding all the areas. You're actually. Okay. Now with that done, now we're going back to stuff like we did before. If you have some right-hand function g of y, some left-hand function h of y, okay? So you want the area between the two functions. Always put the g of y, as long as g of y is always greater than or equal to h of y, then you do the right-hand function on the left, g of y minus h of y, integrate. find things like we did here, but it's fine to do it. This one is horizontally simple. All right, so now let's look at all right, again, y'all have a figure 9 that's not on the slide set, and that figure you see there is horizontally simple from A to B, okay? Because every horizontal line test, the right-hand H of Y is greater than the left-hand G of Y. Anything beyond, above B, you'd have to reverse them. Anywhere below A, you'd have to reverse them. But there it's horizontally simple. Okay. And with that in mind, then the area between two graphs of two vertical functions, basically, what I call it. So you're doing from this function F to function Y, another F. This E is function Y, F of Y minus G of Y. As long as F of Y is always to the right of G of Y. I'm sorry, G of Y is always to the right of just like we did for that, but then at the top and bottom, now we do right and left, the greater minus the left, as long as G of Y is always greater than, or equal to H of Y. So, with that in mind, let's do this one. Okay, and here again, calculate the area enclosed by the graphs of, blow this up so you can read it a little bit better. H of Y is equal to Y squared minus 1, which I think is this blue curve here. No, it isn't. It's the red curve, the pink curve here. That's Y squared minus 1. And G of Y, which is Y squared minus 1/8 Y fourth plus 1. That's this one, the blue curve. Okay? We want to calculate the area enclosed by those graphs. Okay. Now, first and foremost, here's the key. You look at this is function Y. There are no live points here. This is even Y. Function X is the same as plus Y or minus. It doesn't go the same. This one too. All those things are equal. So that's the key function. Because they're both even functions, they're both symmetrical about the x-axis. So therefore we can do our calculation in 0. That's the next section. Confirm what are those functions. So let's see if we can figure those out. How would you do that? Say again. I couldn't hear what you were saying. Oh, okay, wait, yeah. We need to know what the points of intersection are. Let's do that first. How do we get those? Set them equal to each other. So Y squared minus 1/8 Y fourth plus 1 is equal to Y squared minus 1. Okay? And what do you do from here? Yep. Subtract those away. They disappear. Okay. What does that give you? Negative 1/8 is equal to what? Oh, plus 2 is equal to 0. Is that what you said? Okay, I can't hear well. Okay. Say that again. That's a plus. Okay. Say that again. Subtract 2 from both sides. You could do that if you want to. Is that what you're saying? It's okay. I mean, is that what you were saying? I couldn't hear. Okay, yeah. Minus 2 from both sides. Huh? Yeah, exactly. That's why you're just leading me on a wild chase here. Negative 1/8 y4 is equal to. Okay, now what? Okay. Okay, and what would just give you? Say again. y4, 16. Okay. Now what? Okay. Let's do a square root, okay? Okay. So y squared would be 4, and y would be plus or minus 2. Fourth roots are okay, except you might not pick up all the things. You know how to, or you don't? Use the exponent of 1/4. So y is equal to 16 to the 1/4 power. That should do it. Do you have one of those things on here there that look like this? Something like that? Okay, yeah. You could do that too. You could do whatever it is. 16 here and 4. Let's give you plus or minus 2. I didn't know if it would only give you plus 2. My guess is it's only going to give you plus 2. Right. But I knew you knew. I didn't know if you knew. If you take the square root, this gives you plus or minus 4, right? Y squared is the plus or minus 4. Y squared can't be minus 4. So we throw that out. But it can't be plus. Okay, then when you take the square root there, it's plus or minus 2. So that gives you. So those are the points we're going to take. So that's where we're integrating from. But, like I said, I'm going to be really lazy and only go 0 to 2 and double it. So what we'll do then is the integral from 0 to 2 and double this. Now, we need to figure out which is on right, to the right of the other. And we can look at it and see, look, if you hadn't drawn the graph, if this side of the point is commonality here, plus or minus 2, so it would work. What you can do is pick any point there, like maybe 0, where y is equal to 0, and see where that is. And y is equal to 0, that's a plus 1, y is equal to 0, that's a minus 1. So it looks like this one is to the right of it. So you do know what order to do those. So it would be the integral of, you tell me. Perfect. Okay. dy. Okay. 2 times the integral from 0 to 2. Now what do you notice you can do here? Y squared disappear again. So you have a minus 1/8 y to the 4th plus 2 dy. Okay. The 2 times, what's the antiderivative of negative 1/8 y to the 4th? Y to the 5th over 40. Very good. plus 2y. Evaluated from 0 to 2. Okay, I'll do the 0 part, but you do the first part. (32/40) Is that what you got? 32/40 is it? Okay, let's do 2, 4, 8, 16, 32. Right? Okay. 32/40, which would be 4/5, right? Minus 4/5. Plus 4, right? I'll do the 0 part. Done. Okay. So what does this give us? 2 times, isn't that 3 1/5? That would be what? Calculator slow you down. Okay. So, okay. I get that to be 6 2/5. 2/5, which is 32/5. Let's see what they got. 32/5, good for them. All right, I'm so sorry we had such a huge delay with the computer screwing up, and then another big delay when I screwed up on that problem and we just left it alone. We will pick up next time with example 5. We almost finished 6.1. We should have finished it, but didn't. So homework exercises here. Do any of the odds. Let's do either 1 or 3 or both. Do number 5. Do number 7. Do either 9 or 11 or both. And either 13 or 15 or both. Okay. And we'll pick up, now I guess you can probably do either 17 or 19 or both. Do 21. Do either 23 or 25 or both. Do 27. Do 29. Let's see. I think you can do any of the odds 31 to 47. Claims you might need the computer algebra system to do 49. Set it up, take it as far as you can, but if you can't go any further, you can leave that alone. Let's hang on to the rest of them until we finish that last one. Okay? We'll pick up and go from there next time. Okay, good deal. Any questions?